Hello and welcome to the next stage of my home renovation project. Now, today I'm going to be extending the ring circuit from the sockets behind me, just over my shoulder here, to the cupboard just the other side of the hallway here. I'm not going to lift the cupboard floor up and I'm not going to do any chasing just yet, because the priority for me is to get the hallway floor that I'm currently sat on, and you can see the floor, some of the floorboards are up, because I need to get this insulated and I need to get the floor down as soon as I can, just because I'm running out of time. So the actual socket that I'll be mounting in the cupboard under the stairs will happen at a later date, but the cabling will be there in situ, ready to go when I'm ready to do it. So the first thing I need to do is I need to find the circuit that those sockets are on and turn them off. A really easy way for me to find out which circuit these sockets are on is to use my volt stick. This one emits an audible sound to tell me whether there's a current running through the cable, which tells me if it's live. So simply just turn it on and I just put it down onto the cable, and you can see that's giving me an audible signal. Now, they're not 100% foolproof because they do pick up on static, but what it will do is give me a first stage test, so I can go to the consumer unit, turn off the appropriate circuits until I hear the beep go off. Then I know I found the correct circuit, which just saves me having to go back and forth, trying to find it, especially if you're on a large property and you have multiple ring circuits or radials. The other way of testing as well is you can use a plug-in tester. This is just a visual one. It's got three neon lights in it, which tell me whether there's a fault on the circuit, but I don't use it for that. I just literally use it as an on-off, just to clarify whether I have actually got that socket turned off. And then after that, I'm going to get my proper tester out, and just to make sure that the circuit is definitely dead. There you go. Now that's emitting the audible signal, I'm going to go to the consumer unit and turn the circuit off. So as we can see, the volt stick is showing green and it's now stopped emitting the signal, and the socket tester's gone off. So the next stage for me to do now is to remove these sockets, because as you can see, they're not lined up very well. It looks like a bit of a DIY job, so I want to check the electrics behind there, and I just want to check the cabling coming into the back of these sockets and coming back down again, just to make sure there's no spurs and that it is safe for me to work on. It's not been done very well at all, so it was definitely worth me taking this off to have a look. And it also looks like I have a cable coming through the wall, which is coming from the garage. So that's obviously a spur. And this side is actually the ring, because it's coming down and going straight back out the bottom again. Before I go any further, I must reiterate that messing with electrics is incredibly dangerous, and unless you're qualified, you shouldn't touch it. You should always get a professional to come and do it. Because one thing is that just because you turn something off doesn't mean that it is safe to work on. And I'm going to prove that to you right here. So as you've just seen, I've just taken both the sockets off the wall, and I've just explained that this one's coming through the wall from the garage and this one is on the ring circuit. So not only is the live half hanging out of the back of the socket, so that could come out at any point and cause a short circuit against the back of the circuit, or short against the neutrals, could cause arcing and therefore later on a fire. But these sockets are next to each other, so you could assume that they are on the same circuit, but you see, this one's dead because this is the one I had the tester on and what my tester pen was on the cabling for earlier. Now this one, you see, it's still live. So this is blatantly a DIY bodge job. I have a ring circuit on one side with a single socket, and on the other side is the double socket, which has been spurred through the wall from the garage. And another obvious sign that this is a DIY job is that there's no grommets in the back, and they've used gaffer tape. And also, look at that. They're not even level, they're not even straight. It's just been banged in. In their defense though, at least they've earthed the back box. The person who did this only had a vague idea of what they were doing, because they could have just simply taken a spur from here, run the cable through and put it into here, rather than go to the trouble of running a new cable all the way through into the garage, full from the garage. Also, they could, as they went to the trouble of cutting this box out to put a double in, why didn't they just take the single out and turn that into a double? So now I'm armed with this information, I know what to do from here. What I'm going to do next, first and foremost, is put this double socket back on the wall so it's safe for me to work in this area without disrupting too much power in the property, so I can leave the power on. On top of that, the cabling that goes into the bottom of this socket, you can just about see it moving there, which goes underneath the floor, is loose in the wall. So that's a great thing for me, because what I can do, because the cabling that runs underneath the floor here is running in a diagonal underneath the floating floor into the lounge, and I know where the socket is in the lounge. So what I'm going to do is I'm going to pull this piece of twin and earth cable out. I'm going to move it into the cupboard under the floor, and then I'm going to take a new piece of cable from this single socket to run underneath and join onto it, making sure that there's enough slack on the cable so that at a later date I can pull it up into the wall space where the new socket's going to go. So what I'm going to do now is I'm going to disconnect all of this cabling. I'm going to get out my Q-Tech tester, and I'm going to make sure that there's a continuity between all the conductors to make sure that there is in fact a ring circuit in place. The first thing I need to do is just connect my probes together just to check that they're zeroed, which they are. Now I can take them up to the conductors and check the results. So we're starting the lines. .32. It's quite a short ring circuit. Make sure they're nice and tight. 0.33, so that's good because they're very close on resistance. This should be, for the CPCs, 1.67 times greater, so I should be looking at a result, I'm guessing around probably about 0.46, something like that. No, wow, that's very low. So there is a fault somewhere on the ring circuit on the earths. I've got a good idea, I think I know what it could be, but I'd love to hear what you think it is. Please stick your answers or your theories down in the comments below. I've obviously got a fault that I'm going to have to track down at some point, but because the floor's up and I need to get the floor back down, I'm just going to have to get this cabling into situ, get it ready to be worked on later on in the future, and then come back and fault find later on. So as you can see, I've got the new cable here, and I've taken the CPC or the earth line and I've twisted it together with the original cable. I've also had a little bit of tape on the end there just to help stop it from catching as it goes down the tunnel behind the wall. So that will just go up tight, as close as I can get it. I'll wrap a bit of tape around those in a second, so if I do need to pull it up again, it's less likely to snag. And the reasoning behind this is because it's a lot easier for me to try and pull a cable through at the same time as taking an old one out, because it will follow the same channel, than trying to pull the old one out and then fight for ages trying to get the new piece to follow the same route. Now this is always the fun part. You need to make sure the orientation, especially on these old buildings, if the cable has actually been cemented into the wall rather than conduit being used, or even if they've just used a tiny bit of conduit. You haven't got the direction of the twin and earth in the right direction to start with, it's just not going to go. You see it's all started to twist there already. And you see I've just pulled the rubber grommet. Well, I can just pull that up out of the way. You see, these things don't always go to plan first time. I'll wrap some more tape around that. And I can just about see on the edge though, actually there is a bit of trunking, which is great. And there we go, that has gone to plan on the second attempt. You do have to be careful though, because of the rubber grommets out of the way, that I don't shave any of the insulation off on the inside of the back box. So let's get that grommet back in place. So here we see the new cable's going down in. I need to fix the grommet in there properly, which I'll do in a second. But the new cables come out from underneath. You can see where the old one's attached. So all I need to do now is break the connection here and take them over to where the new socket's going to be, under the floor down there. What I've also done with the new cable is I've just added a piece of 16mm oval trunking or conduit. Now the reason behind that is because in here, along with the rest of the spaces between the joists, is where the polystyrene insulation is going to go. There's a chemical reaction that happens between the PVC cabling and a chemical that's in the polystyrene, whereby they will just weld themselves together, therefore destroying the insulation properties of the cabling themselves. So you need to have a protective barrier between any cabling and any form of polystyrene. But it's a good thing to do anyway, to just give that cabling just a little bit of extra protection, whether you've got insulation there or not. So moving on, as you can see, I've got the cable running all the way underneath the joist. Make sure you go underneath pipe work, and there we have the old end and the new end. So I just need to continue feeding it through underneath, and now it's a case of joining these two ends together, checking I've got a ring circuit still of this end, and then I can put the socket back on and turn the power back on. I always find it easier just to start off with clean ends, so I always just snip the ends off, start again from scratch, especially when I'm making a new connection. And in this case this is a temporary connection, so the ends don't have to be particularly long, although they need to be a bit longer than that. And then I can join the two ends of the cables together and put them into a junction box. So you mustn't forget to sleeve. Where's my snips gone? And in this case you're also going to be careful, because this is the old style colours against the new styles. So red will be brown, CPC will obviously stay the CPC, green and yellow, and the neutral here, which is black, is blue in the newer colours. As you can see, like I just said, brown and blue colours, not even neutral. I'm just using 3mm sleeving. As you see, I've cut this one a little bit short on the neutral, so I'll strip a little bit more off. Put them in. Own, because I'm having to both look at what I'm doing in real life and through the lens actually see what I'm doing. And then just turn over the Wagos just to make sure that the cables have actually gone all the way in and they are fully connected. Just put that, close it up and make sure that's in there. Now ordinarily, if this was going to be a permanent connection, I would use the strain relief and screw it in and put a screw in the box. But because, like I said, this is going to be a temporary situation whereby I'm just going to leave this under the floor for a little while, because it is another job that I will be doing later on, then there's no point in having to do the same job twice or making your life more difficult later in the future. So now I can just put this into a bit of a loop and just tuck it
up out of the way. It's highly unlikely that it could ever happen, but just to be on the safe side, as you can see, I've actually bent the cable up and kept the connection up a few inches, so that in the highly unlikely event that one of these pipes were to burst and the area underneath the floor here would fill with water, or if there's a flood outside, for example, the water won't affect the connection point before I've had a chance to work on it. I now need to just double check all these connections for continuity, so we do line to line, 0. There we go, 0.39, neutral to neutral, time a little bit, there we go, 0.39, settled down, and the CPCs 0.3332, just pretty similar to where it was before, so there is definitely a fault, like I said, on there, but at least now I can put the socket back on. I can continue with the tests that I need to do, and if you're an electrician you know what those tests are going to be, and I can turn the power back on. In the near future I'm going to be replacing the consumer unit, and I'm going to be lowering it down to a level that I can actually reach all the MCBs, or in the case of the new fuse box when I fit that, all the RCBOs, so that I don't have to keep climbing up steps every time I need to turn something on or off. At that point I will need to test the entire property, and knowing that there is a fault on this circuit, I'm going to have to find and repair that fault before I can actually physically change and sign off the new board. So as you can see, the power's back on the socket, so I've reconnected it all. I've purposely left out certain stages that you do with the testing and with fitting of the cabling and other parts of the job, because electricity should not be taken lightly. You should always seek a professional to work on it. Never ever do DIY electrics, because long story short, it can kill. So anyway, thank you for watching. I hope you found this educational, or at least informative, and I shall see you very soon on the next video. And if you have any comments or questions, please don't forget to leave them down below. See you soon.